title of my talk is Detecting Time Zones in the Browser, Are You a Freaking Masochist? Because time zones are hard and time zones have had a lot of problems with developers. There's a joke that goes around Twitter every now and then of you can tell a developer by just mentioning the word time zones and watching them cringe. I'll just start with a quick introduction though. You'll find me on the internet generally looking like one of the top 2 pictures. So I'm Gilmore less in various different systems. I am not your broom on Twitter, and I very occasionally write things at a site that doesn't have a logo. So I'll start with a common problem on the web, which is the server has a concept of now, and it outputs a date or a time and goes, all right, there you go, that's what time this thing happened. But depending on where your users are, that now isn't actually now for them. It could be in the future, it could be in the past, but there's no indication given. And this is actually a very common problem in Australia, where a lot of servers are in San Francisco, and times that are 17 hours behind us aren't particularly useful. It's even worse when you're presented with a UI that makes you write the time for a scheduling system. There's some examples there from popular software. If there's no indication of what time the server thinks it is, how are you meant to know when something's going to happen? So there's actually a very, very simple solution to this, which is to just not ever show date or time. It's perfect, we're done. Thanks for listening. Except that's not actually particularly practical. So we'll try a different solution. Just basically, you can make the conscious choice to output only server time and at least indicate what time zone that's in, and then say, all right, deal with it, you work it out, but here's what we've got. But really, that's not actually a solution either. It's just the problem again. So to have a look at why this is a problem, let's actually look at how time zones work. This is clearly a draft edition. All right. So time, hundreds of years ago, there was just the concept of local time, and it was based on the sun. When the sun's at the highest point in the sky, it's noon. But depending on where you were, everyone had different versions of local time. And this wasn't a problem that the village down the road was 8 minutes off until you got to telegraphs and railways and people started travelling long distances, and suddenly it actually became a bit of a problem. So obviously they need to work out some sort of standardised system. And back in 1879, I think it was, someone kind of came up with the idea of, well, there's 24 hours in a day, you divide the world up into 24 bands, works out to 15-degree longitude bands, you just work out where you are in the world and assign a time based on that. So it was a nice, perfect solution. It was mathematical, it was precise, it was easy to calculate, especially for software later on. And like all perfect solutions, it remained perfect right up until the time it met reality and became completely impractical. Because this is what it actually looks like. The nice, neat bands aren't quite so neat anymore because they've hit country boundaries and state boundaries and politics. And this doesn't even include daylight saving time differences. So obviously there are discrepancies when you're starting to warp boundaries like this. And this is actually some great work by a guy called Stefano Macchiolo. I assume I'm pronouncing that right. Basically the green on this map is where the time zone is ahead of mean solar time, and the red is where it's behind. So you can see Russia and China are particularly behind due to using, China touches, I think, something like 8 different time zones across its borders, because it borders 15 countries, but it's all on one time zone. So the parts in the far west of China are actually 3 hours behind mean solar time. So obviously, if you're trying to write a system based on this, it's a real headache, and you need some sort of common reference point. Now, everyone would have heard of Greenwich Mean Time, but this is a tech conference, so we use the technical definition, which is UTC. So what does UTC actually stand for? Well, the answer is nothing. The International Telecommunication Union and the International Astronomical Union, when they were defining the standard, they wanted to have the same acronym for every language in the world. And the English and the French, of course, didn't actually agree on what that acronym should be. So in the end, a compromise was made and everyone is equally wrong. So how does UTC actually relate to GMT? Well, if we use JavaScript notation and equality checks, they're pretty much the same. It's just that UTC is more scientifically precise. If you want to think of it in software terms, GMT is deprecated. Okay, so we've looked at the history of time zones a little bit. So now you think, all right, I know a solution. I can get the user to pick their own time zone, and I'll just convert all the dates into that, which now presents other problems. So my talk is actually briefly, it's mostly about the browser, but I'll give a quick token mention to Node to make sure my presentation is web scale. You'd set process.m.tz equals time zone name, and all your date calculations after that will be in the appropriate time zone. So you give the user an option to select from a nice, simple list. This is how to pick the Sydney time zone for various pieces of popular software. So as I mentioned in the slide before, there are 423 time zone definitions at the moment. There's still more being added all the time. So every time zone picker that you give your user is a trade-off between the ease of use and the actual comprehensiveness of the list. So at this point, you need to ask yourself, do you even really need to store the user preference? Because what are you really trying to achieve? You're just trying to take a date and a time and display it in a way that's relative for your users. So what you do is you only ever reference UTC. Your server stores UTC, your server outputs UTC, and as a side note, you should only ever store UTC anyway, because otherwise your date calculations for adding and subtracting dates is going to get really hard. So the server just outputs UTC, and then you convert it to local time in the browser without actually knowing what the time zone is. This is by far the best solution, and it's used by a few popular sites. Like, I'm sure the GitHub people can tell you that that's what they use in the web UI. And the really, really basic implementation looks like this. You have an HTML5 time element, which has the date-time attribute. This is using the ISO standard date-time format. The Z at the end of the string stands for Zulu, which is just another word for UTC. Of course it is. Zulu actually comes from a nautical term where they had defined letters of the alphabet for each zone that they went through, and Z was their reference. So you grab the elements, you quickly loop through them, you get the date-time attribute, pass that straight into a new date object, which recognises the ISO format, but it has then converted that UTC absolute timestamp into your local time, and you can just output it in some way that probably is more friendly than toString. You could use a library like Moment to get friendlier dates. So do you really need to store a user preference? Unfortunately, sometimes you do, because you could be working with software that needs to reference it in the back end for some reason. It could be scheduling automated alerts. So now we come to the part where you really need to ask yourself what you're doing. Because, okay, we've got some time zone information in the browser, surely we can just detect it for them. Yeah, good luck. So the idea is simple. You grab a new date, you use the one method that we have available that has anything to do with time zones, which is get time zone offset, and this returns your local time minus UTC as a value in minutes. '" 'So for where we are right now, that returns minus 600. If it was a couple of weeks ago, before we moved out of daylight savings, that would be 660. So the idea is then you just map the offset to a list of time zones and just do a quick lookup and we're done. No, not at all. So to understand why this is a problem, we'll take another little detour. About 4 years ago, a guy called Patrick McKenzie wrote a blog post called Falsehoods Programmers Believe About Names. And this was a very widely spread article. I'd highly recommend you go find it if you haven't read it. This was based on his experience working in translation software, and his name, he went by any one of 6 different names, and he generally broke software whenever he tries to use it because it made certain assumptions about the way names were formatted. Now, this was referenced a couple of years later by Noah Sussman, who wrote Falsehoods Programmers Believe About Time. And this was mostly to do with hours, minutes, seconds, timestamps, and included the fun example that particular VM software, if it suspended the VM, it suspended the clock, and when it resumed, perhaps an hour later, that 1 second could have lasted an hour. This got spread around Reddit and Metafilter and Hacker News, and he got overwhelmed with responses. And 3 days later, he wrote his follow-up post, which contained 79 different falsehoods, all gleaned from user comments, all of which were mistakes that people had seen in software dealing with time. Now, I'm not going to... There's the full list on the right, but I won't read out all of them. I will just pick out a few of my favourite ones. Like, the local time will not change during office hours, which is wrong. Reading the client's clock and comparing to UTC is a good way to determine their time zone. Yeah, no. And I can easily maintain a time zone list myself. So, problem number 1 with time zones is daylight saving time. First of all, some countries use daylight saving, some countries don't. For those countries that do, not all the states and territories use daylight saving. Australia is a great example of this. When they do use it, they don't all change at the same time of year, and if they do change on the same day, they change at different hours of the day. Some countries don't change only twice a year. Morocco, for example, bases its dates on Ramadan. So they go into daylight savings, and when Ramadan starts, they come out of daylight savings 1 month so that it's easier to fast during daylight hours. And then they go back into daylight savings for about a month and a half and then come out again. And not every change into daylight saving is by 1 hour. Most of them are. But Lord Howe Island changes by half an hour. So that for 6 months of the year in winter, it's half an hour ahead of Sydney. And for the other half of the year, it's on the same time as Sydney when Sydney jumps forward an hour. Why they do this, I have no idea. But it's something software has to account for. Now, when I was looking at time zones, I actually gave myself an excuse to play with D3 and did a visualization of different time zones and their daylight savings implementation. Now, the details aren't really important, but what it shows is there's a hell of a lot of variation. And now we come into the second major problem, which is changing the rules, because they just make up the rules all the time. Countries and regions are constantly changing what their base offset from UTC is. Russia is the prime case of this, where they are arguing every year about whether they are in permanent wintertime or permanent summertime, and they've changed their minds about 3 times over the last 5 years. They're still trying to change it again. Regions can decide to start or stop using daylight saving time even while they're in daylight saving time. Jordan, for example, in March 2012, just before daylight saving time ended or was due to end, they decided, you know what, we're just staying in summertime all the time, permanently. They actually thought that it would save them electricity costs throughout the year, and they wanted to see if it worked. A year and a half later, after massive protests from, amongst others, the Jordanian Teachers Association, who were worried about students walking to school in the dark in the morning, they ended up switching back. The start and end dates of daylight saving time are constantly changing, and sometimes you get advance notice and sometimes you don't. And then my favourite example is that for Samoa, the date of December 30, 2011 doesn't exist. So they went straight from December 29, crossed the international date line at midnight and went straight into December 31. The reason they did this actually made sense, is they wanted to increase the number of days they could trade with Australia and New Zealand. But their nearest neighbour, American Samoa, wanted to stay trading with America, and so the two neighbouring islands are now separated by 48 kilometres and 24 hours. Which brings me to the big point, which is politics, because this actually just causes most of the other problems we've seen. If you want a great example of politics, Spain is currently in debate as to whether they should change their UTC offset. They're currently UTC plus 1 hour, but that only happened because Franco wanted to align with his Nazi allies and so switched to the same time as them. A lot of Spaniards don't like this and they want to move back. Still in debate. There are non-official rules. There's a town called Eucla, near the border of Western Australia and South Australia, which actually has decided to pick for itself a time halfway between Adelaide and Perth. So they use UTC plus 8 hours and 45 minutes. The best thing about this is that the Australian government doesn't recognise that time zone. So Australia actually has 8 different time zone rules, but the government only recognises 7 of them. But software still has to account for it because this is what the people in that town say they use. There are one-off changes. Sydney decided to extend daylight savings earlier during the 2000 Olympics. Turkey recently delayed the start of daylight saving by just 1 day because they had local elections. And then there's the ones that are just made up on a whim. So the decision for Jordan that I mentioned before, we're just going to stay in summertime. They announced that only 2 days before daylight savings were meant to end, which actually caused havoc with pre-printed flight tickets. And they just had to tell everyone to turn up to the airport an hour earlier than their ticket. Thankfully, the airlines use UTC and they weren't affected. Morocco extended daylight saving time by a month, only 1 day before it was meant to end. And as I mentioned, their dates are based on Ramadan, which is a lunar cycle. So the dates in the future are currently just a best guess. So how the hell do you keep up with all of this? Well, there is the official IANA Timezone database, which was started by Arthur David Olson back in the 80s and has been kept up by a steady list of dedicated maintainers. And it moved to IANA after there were some legal complications, which did get resolved. But now it's got a better controlling master. And this is actually used in most software that we use today. So Linux and Mac operating systems, they have this as their standard reference. Windows, of course, doesn't. They use their own shit. But the key thing is that you need to keep your definitions up to date because, as we've seen, countries are changing all the time. By my count, there are 5 different places in your website where these definitions could get out of date. So you've got the server's operating system, the software, which could just be the programming language, the libraries that are built for that, which could bundle their own definitions, the user's operating system, and then if you're adding in client-side libraries. All of these can have different definitions of what a time zone is and what its rules are. So the question I'm asking is, do you really need to add in a client-side library that deals with time zones? Having said that, there are There are actually some people who have put an impressive amount of work into trying to get this to work in JavaScript. Moment Timezone, for example, pulls in the IANA database as a Git submodule and then compiles it using grunt. You can select which zones you want the JSON definition for, but the problem is that if you want all the time zones, that JSON file is going to be over 100 kilobytes. And if you're loading that into a mobile browser, you can imagine, especially as more definition comes through, that's not actually a great thing. So I'm trying to avoid the problem completely, because this is not just a historical problem. This is a list of all the IANA database changes in timezone rules since the start of 2012, which doesn't look like a particularly long list until you actually scroll through it. There we go. But that doesn't actually include the latest change, because as I was writing this presentation, a change came through which summed up a lot of my points really neatly. It was hard to predict in advance, and it was really politically motivated. So 2 weeks ago, Crimea jumped forward 2 hours to align themselves with Moscow. But should you actually care? Well, unfortunately, the users of your software really might care. And I can tell you from bitter personal experience. So, to finish up, Atlassian's issue tracker, JIRA, it's widely used around the world. And just after I started at Atlassian, it gained the ability to set a user time zone preference. Now, I felt that this feature wasn't getting enough use. I was looking at the stats on our biggest public instance of JIRA, and almost no one was using it, the time zone feature, that is. So in 20% time, I wrote a little plugin to try and detect the time zone in the browser before I knew all of this background, and just make it a one-click operation. So I used one of those libraries I mentioned before, JSConf.au detect, which worked really well for what I wanted. And I showed a little banner saying, we think your browser's in a different time zone from what your preference specifies. Just click here, and it's set. The library isn't 100% accurate because it just picks one major city per collection of time zones. So most of Western Europe is just detected as Berlin, which works fine for what I wanted because the rules are all the same. It actually goes through and has some disambiguation code for rules, the zones that are similar but have different daylight saving start dates, so I can work on that with certain start and end dates. About a year later, I wrote a blog post on our developer blog showing statistical analysis of how it had been used. The time zone feature usage had increased 16-fold in the year that it had been implemented. Now, during the time, I'd been aware that the feature would need maintenance due to zone updates, and I'd committed back to the library via pull requests when Samoa crossed the date line. But I didn't realise how bad things could actually get. So the problem started last year when Israel changed the starting date of daylight savings time, which wasn't a particularly big deal on its own. But when it was combined with the hard-coded date disambiguation code in the library, it caused quite a problem. But this didn't happen, so Israel changed the rules. Then it had to go into the IANA database. Then that had to be compiled into software updates. And then it finally came down to the users. And when they upgraded their operating system, JIRA started telling them they were in Gaza. So down the bottom is the public bug that we raised about it, and one of the comments where they actually say this is both incorrect and very offensive. Now, I don't know about you, but when I started in the tech industry, I didn't really have career goals. I just thought I'd play it by ear. But I'm pretty sure that if I did have career goals, that on that list would not be increased political tension in a long-standing conflict in the Middle East. So obviously, couldn't just let this go, I had to fix it. And the quickest way would just be submit a fix to the JS Timezone detect library, try and work it out. Two problems with this. In the year and a bit since I first wrote the feature, the library had had a refactor and had removed an API that I relied on, so I couldn't just quickly patch it. And the other one was that I realized this could probably happen again in the future with a different set of countries. So it was actually time to just completely rethink the approach. So some basic architecture is this is how it was working. I would check the user preference that they had stored in JIRA, call out to the detection library. If they differed, give the user an option to set the new zone. And the way JS Timezone Detect actually worked basically is that it would create a date in January and create a date in June, to compare the so the UTC offsets, and if they differed, well, that country had daylight savings and there could be further calculations from there. So what I wanted to do was actually get rid of that bit, and we already had time zone definitions on the server, so I started detecting the offsets myself, asked JIRA backend to find all the zones that it had to find that matched that offset pair, and then show the user a list so that they could select which one was relevant to them. So this is the newer version. I'll just zoom in on that. So that's for where we are right now. And for anyone wondering, Curry is a zone for an island in the Bass Strait. But all these 4 zone definitions here have the exact same time switching, but they have their own names for historical reasons. So obviously, this working 100% correctly still relies on the back end having the right definitions, but we already had that problem anyway. And now, if things are going to be out of date, the front end and the back end are at least out of date in a consistent way. And there were extra hassles I found while doing this. So automated testing. You can never be sure what time zone your build server is running in. So I tried to mock the date object. And given how many different arguments its constructor can take, that's not a good idea. So in the end, I actually just created an abstract method, I think it's called something like get offset for month. And then I just mocked that to return hard-coded values in my tests. Manual testing. When you change your computer's time zone so that you can test that the feature's working properly, Firefox gets the update just fine. It changes its zone, your new date calculations are fine. Chrome just ignores it completely. But that's actually better than what it used to do, which was reset to UTC. The worst part, though, is when you have changed your machine time, and then you forget to change it back, and wonder why all your instant messenger conversations are logged at 2 o'clock in the morning. Windows, as I said, doesn't use the IANA database. This wasn't specifically a problem for me with the JIRA implementation, but other software providers do actually have to worry about this. There's a standardized mapping between Windows time zones and IANA time zones, and they're mostly similar, but there are some discrepancies. And I had some people ask me about, oh, why don't you just try and detect their location? Yeah, so if you think time zone disputes are bad, don't even start looking into border disputes. Basically, Windows used to have a map for selecting a time zone in its software. They removed that because the number of people who complained from India and Pakistan about where the border should be on the map just forced them to just go, nah, screw it, we're just taking it out. And if you're worried about 100K of just time zone definitions, I can't imagine what the polygon data for time zone shapes would be. So I'll just finish quickly with some big takeaways. And as an aside, if you do a Google image search for world record food, it's really disturbing. So the first one is, do you really need a time zone? Or do you just need to output the time in a way that's relative for the user? Most of the time, all you're going to need is just relative time. But if you are going to do a time zone, make sure you do it properly. Which brings me to the next point, which is don't ignore history. Despite what some people in the JavaScript community might think, problems existed before JavaScript, and problems were solved before JavaScript. We are not special. Time zones are really freaking hard, and a lot of people have spent decades trying to make them easier for everyone, and we should learn from their work. Thank you.